Alright, in this video I'm going to cover a couple of problems from classwork 1.3 where we're using our constant acceleration equations. Let me go ahead and do number 36 to start with. So classwork 1.3, this is going to be number 36. And I'll just read the problem. It says, a foul ball is hit straight up into the air with a speed of about 25 meters per second. How high does it go? How long is it in the air? Okay, so first I'm asked for part A, I'm asked how high, okay, and for part B, I'm asked how long is it in the air, okay. So for part A, really what I'm asking is I'm asking displacement, okay, from the point where you threw it to the point where it ended up, okay. And some of the information that I am given, okay, is I know that my initial velocity is 25 meters per second, okay, and then there's a few assumptions that I'm going to make. So if I just draw a motion diagram of this, okay, I know at the very bottom that's where I'm going 25 meters per second, but when I get to the top up here, where I'm at my maximum height, I stop for a minute, right? So I could say my V final is 0 meters per second, okay? Now, the other thing that I can assume is because it's flying through the air, I know gravity. So acceleration is negative 10 meters per second squared. All right, so I have V initial, I have V final, I have A, and I'm trying to find D. So the equation that I'm going to use then is that V final squared equals V initial squared plus 2AD. Okay, and then I just go ahead and plug in what I've got. So V final squared is 0 equal to 25 squared plus 2 times a negative 10 gives me D. 25 squared is 625. Right, so negative 625 equals negative 20D. So just divide by negative 20, divide by negative 20, and I get 625 divided by 20, 31.25 meters. So the displacement is 31.25 meters. Okay? Now, the second part is pretty easy, right? I've got V initial and I've got V final. I have A, now I have D. There's lots of different ways that I'm going to solve this. But I'm going to solve it just pretending that I don't know D because I want to show you something really important, okay? How long would be T time? So I have V initial is 25 meters per second. V final is 0 meters per second. A is negative 10 meters per second squared, and I want to find time. Okay? Now, the best way to do this, if I'm solving this manner using this V initial and this V final, I'm not solving for the question how long is it in the air. I'm solving for the question how long does it take to get up to the top of its path. But because I know how long it takes to get up is equal to the amount it takes to get down, all I have to do is multiply my answer by 2. Okay? So given these variables, I'm just going to use this equation. Acceleration equals V final minus V initial all over T. Okay? If I solve this for time, I'm going to multiply by time on both sides, and it'll cancel there. And then I'll divide by A. So I get that T equals V final minus V initial all over A. Because A is 10, this makes this really easy. We get 0 minus 25, okay? So that would be a negative 25 over acceleration, which is a negative 10. T equals 2.5 seconds. That's really important to recognize. I throw something up in the air in 25 meters per second, it takes 2.5 seconds to get up to the top. If I throw something up in the air at 60 meters per second, it takes 6 seconds to get up to the top. Okay? Now the question asks the total time, so 2.5 seconds up, 2.5 seconds down, T equals 5 seconds. Okay? So keep that in mind because that is a really quick way to answer this question once we recognize that. If I were to give you a problem on a test and it said, A ball was thrown straight up in the air at 50 meters per second. How long is it in the air? You should immediately, without having to do any math, say 10 seconds. 5 seconds up, 5 seconds down. Okay? So commit that to memory. Alright, let's go ahead and do number 41. Number 41 is the helicopter problem. Okay? A helicopter is ascending vertically with a speed of 5.5 meters per second. Okay, so I'm going to put this into my given section. So I have a V initial of 5.5 meters per second. Okay? It says, at a height of 105 meters above the earth, a package is dropped. So if you drop the package from a height of 105 meters, it will actually, like, let's just draw the helicopter. I'm going to attempt to draw a helicopter. I'm probably... Oh, that's not too bad. Okay, so if the helicopter is going up, when you first drop the package, essentially, it's going up too. So it's really going to fly like this, okay? Because it's going to go up until it comes to a stop and then go till it hits the ground, okay? However, that really doesn't matter because it still started 105 meters above where it ended up. So D is still going to be a negative 105 meters down. It doesn't matter that it went up a little bit first and then came down. Because remember that D displacement is your change from your original position, which is from here to here, no matter how you went about it, okay? So we'll write that down here. So D is equal to negative 105 meters, okay? Let's see what else information it gives us. That's it. It says how much time does it take for the package to reach the ground. So what am I being asked? I'm being asked to find T time, okay? Now, of course, because something's flying through the air, and we know these are constant acceleration equations, we have gravity, which is the negative 10 meters per second squared. Okay? Given this information and trying to solve for t, I should recognize that the equation that I want to use is d equals v initial t plus 1/2 at squared. Okay? And then I just plug in my numbers. So I get negative 105 meters equals 5.5 t. I'm going to kind of cut this out just so we can see what kind of equation this is. Plus 1/2 of a. So 1/2 of a is actually a negative 5t squared. Okay? So by looking at this, you should recognize, because I have a squared term here, that this is the equation for a parabola. If we look at our motion here, right, that is a parabola, okay? And what we want to solve for is time it takes to hit the ground, okay? So when we have an equation like this, a quadratic like this, we're going to get two numbers, okay? So if I'm going to kind of rearrange this so it looks the right way to me. This looks backwards to me, okay? And then I'm going to also kind of factor it down just to make it a little bit simpler, okay? So I'm going to move this, I'm going to add 5t squared over here, okay? So 5t squared minus 5.5t, and then minus 105 equals 0. Okay? Now, I can even reduce this down even further, right? So if I divide everything by 5, I would have like t squared, and I'm just trying to do this so it makes it easier. You can just punch it into your calculator if you want. So you have t squared minus 1.1t minus 21 equals 0. Okay? Then we're going to plug that into our quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Make sure that you remember this. And I'm not going to go through all the steps of this. You can punch that into a calculator, but always with a quadratic, remember that you get two answers because you're getting both intercepts. So the answers that you get is t equals negative 4 and t equals 5. Okay, well, which makes sense? -4 seconds or 5 seconds? 5 seconds is the only thing that makes sense because time is a scalar. Okay, so it's going to take 5 seconds for it to hit the ground. The -4 number comes from if you were to throw the package from the ground, or sometime it would take 4 seconds in the past to get up and then fall back down. Okay, so that's where the -4 comes from. But of course, time is a scalar, so 5 seconds would be the answer. In the next video, I will do some of the more challenging problems at the end, where things are thrown up and off cliffs and past windows.